The name sounds like something from a spy movie. The axis of evil. It sounds sinister, planned, and powerful. But in cosmology, it's not about villains or secret plots, it's about a puzzle. A very big puzzle written across the entire sky. It's a glitch in our understanding of the universe. It's a hint that maybe, just maybe, the story we tell ourselves about the cosmos is missing a key chapter. To understand the axis of evil, you first have to understand what it's found in. It's found in the oldest light in the universe. This light is called the cosmic microwave background, or CMB for short. The CMB is the afterglow of the Big Bang. It's a faint, cold echo of a time when the entire universe was a hot, dense, glowing fog. For the first 380,000 years after the Big Bang, the universe was too hot for atoms to form. It was just a soup of particles and light all mashed together. Light couldn't travel far before bumping into a particle. The universe was opaque. Then, things cooled down enough for protons and electrons to combine and form hydrogen atoms. Suddenly, light was free. It could travel across the universe without constantly being scattered. That first burst of free light has been traveling ever since, and as the universe expanded, this light has stretched out. It started as hot, visible light, but over 13.8 billion years of expansion, it has stretched into the microwave part of the spectrum. It's now incredibly cold, just 2.7 degrees above absolute zero, but it's everywhere. No matter where you point a radio telescope in the sky, you will see this faint microwave glow. It is the backdrop to everything else. For a long time, scientists thought this glow would be perfectly smooth. The Big Bang happened everywhere at once, so the afterglow should be the same temperature in every direction. When scientists first measured it with real precision in the 1990s with a satellite called COBE, they found it was almost perfectly smooth. It was a stunning confirmation of the Big Bang theory, but almost is the key word. They also found tiny, tiny temperature differences. Some spots in the sky were 100,000th of a degree warmer, and some were 100,000th of a degree colder. These are the famous hot and cold spots in the CMB. These little fluctuations are incredibly important. They were the seeds of everything we see today. The slightly denser, slightly hotter spots had a bit more gravity. Over billions of years, they pulled in more and more matter, eventually forming the first stars, galaxies, and the massive cosmic structures we see today. Our own Milky Way galaxy grew from one of these tiny seeds. According to our best theory of the early universe, called cosmic inflation, these seeds should be completely random. Inflation theory says that in the first fraction of a second after the Big Bang, the universe expanded at an unimaginable speed. This smoothed everything out, explaining why the CMB is so uniform, but it also magnified tiny quantum jitters into the temperature fluctuations we see. And quantum jitters are, by their very nature, random. So, when we look at a map of the CMB, we expect to see a random splattering of hot and cold spots, like random static on an old TV screen. There should be no special patterns, no preferred directions, no alignments. This idea is part of a bigger principle called the cosmological principle. It's a foundational assumption in modern cosmology. It states that on the largest scales, the universe is homogeneous and isotropic. Homogeneous means it's the same everywhere. Isotropic means it looks the same in every direction. There are no special places and no special directions in the universe. Our position in the cosmos is not privileged. This is an extension of the Copernican idea that the Earth is not the center of the universe. For a long time, everything we saw supported this idea. The CMB map looked pretty random. Then came a satellite called the Wilkinson Microwave Anisotropy Probe, or WAP. Launched in 2001, WAP was designed to map the CMB with much higher resolution than ever before. Its data was beautiful, it gave us a stunning baby picture of the universe, and as scientists analyzed this picture, they started noticing something strange. When they looked at the largest patterns in the sky, the biggest hot and cold spots, they didn't seem to be random. They seemed to be lined up. There were a few very large-scale patterns that were unexpectedly aligned with each other. It was as if you threw a handful of paint at a wall, and instead of a random splatter, you found that the biggest blobs formed a straight line. This alignment pointed to a specific direction in space, a special direction, a preferred axis. This was the first hint of trouble. This alignment was dubbed the axis of evil by the scientist who discovered it, João Magejo. The name was a playful nod to the political term used at the time, but it captured the feeling that this was a deeply unsettling and potentially dangerous discovery for the standard model of cosmology. It was evil because it threatened to destroy our simplest and most elegant theories about the universe. The problem got even weirder. Not only was there a preferred axis, but the orientation of that axis was suspicious. It seemed to be aligned with our own little corner of the universe. It pointed roughly towards the Virgo constellation. And more troublingly, it seemed to be roughly aligned with the plane of our solar system, the path the Earth and other planets take around the Sun, known as the ecliptic plane. This was a huge red flag. Why on earth would a pattern from the beginning of the universe, a pattern that spans the entire observable cosmos, be lined up with the dinky little plane of our solar system? The solar system is a tiny, insignificant speck in the grand scheme of things. It formed billions of years after the CMB was released. There's no known physical reason why the two should have anything to do with each other. It violated the Copernican principle in the most profound way. It was like finding out that the cracks on a randomly broken plate just happened to spell out your name. The chances of that being a coincidence are incredibly small. It suggests one of two things. Either you are incredibly, unbelievably special, or there's something wrong with how you are looking at the plate. So the axis of evil presents two major problems. First, the alignment of the largest patterns in the CMB violates the principle of isotropy. It suggests the universe has a preferred direction. Second, the alignment of this cosmic axis with our local solar system plane violates the Copernican principle. It suggests our location is somehow special. So what could possibly be causing it? Scientists have been wrestling with this question for years, and the explanations generally fall into three categories. The first is that it's a fluke, the second is that it's a mistake, and the third, most exciting possibility, is that it's real, and it points to new physics. Let's start with the fluke idea. It's possible that this is just a giant coincidence. In any random dataset, you can sometimes find weird patterns just by chance. If you flip a coin 1,000 times, you might get a run of 10 heads in a row. It's unlikely, but not impossible. Maybe the universe just happened to produce a CMB with this strange alignment. We only have one universe to observe, so we can't run the experiment again to see if we get a different result. The problem with this explanation is that the alignment is statistically very significant. The odds of it happening by chance are low, something like 1 in 10,000. That's low enough to make physicists uncomfortable, but not low enough to rule out chance completely. So it's possible, but it's not a very satisfying explanation. Scientists don't like to appeal to pure luck. The second category of explanation is that it's all a mistake. This is where most of the work has been focused. Making a map of the CMB is an incredibly difficult process. The signal from the early universe is extremely faint. It's buried in a sea of foreground noise. Our own Milky Way galaxy, for example, emits a lot of microwaves from its dust and gas. This galactic light is thousands of times brighter than the CMB signal we're trying to measure. To see the CMB, scientists have to carefully model all of these foreground sources and subtract them from their data. It's like trying to hear a faint whisper while standing next to a jet engine. The process of cleaning the data is complex and involves making assumptions. It's entirely possible that we are not subtracting the foreground light correctly. Maybe some residual light from our galaxy or even from our solar system is contaminating the final map and creating the illusion of an alignment. The fact that the axis aligns with our solar system plane strongly supports this idea. Perhaps there's a faint cloud of dust in our solar system that we haven't properly accounted for. This dust would lie along the ecliptic plane and could be creating a microwave signal that we are mistaking for a cosmic pattern. Scientists have worked tirelessly to check for these kinds of errors, called systematics. They have reanalyzed the data over and over, using different methods to clean the map. When a new, more powerful satellite called Planck was launched by the European Space Agency, the cosmology community held its breath. Planck would map the CMB with even greater precision than WMAP. Would it confirm the axis of evil, or would the anomaly disappear with better data? The Planck results were a mixed bag. The good news for the standard model was that Planck's data suggested the alignment might be slightly less statistically significant than the WAP data indicated. The bad news was that it was still there. The alignment didn't go away. Planck saw the same strange patterns on the largest scales. It even found other weird anomalies, like a giant cold spot that is too big and too cold to be explained by standard theories. So, while the evidence for the axis might be a little weaker, it certainly hasn't been disproven. The idea that it's just a simple error in data processing has become harder to defend, because two independent experiments with different instruments have now seen it. This brings us to the third and most mind-bending possibility: the axis of evil is real. It's not a fluke, and it's not a mistake. It's a genuine feature of our universe. If that's true, then our standard model of cosmology is wrong, or at least incomplete. We would need new physics to explain it. What kind of new physics could create a preferred direction in the universe? There are several speculative ideas. One idea is that the universe isn't shaped the way we think it is. We usually assume the universe is infinite and has a simple, flat geometry, but it could have a more complex topology. For example, the universe could be finite but wrapped around itself, like the surface of a donut. If you traveled in one direction long enough, you'd end up back where you started. In a universe with a weird shape like this, the patterns in the CMB could be constrained. They wouldn't be able to form in any random orientation. The shape of the universe itself could impose a kind of global alignment, creating a preferred direction. Some models of a donut universe do predict patterns similar to the axis of evil. Another idea is that something happened before the Big Bang, or during the earliest moments of inflation that left an imprint on the universe. Our standard model of inflation assumes it was a very simple, uniform process. But what if it wasn't? What if there was some kind of field or force present in the primordial universe that had a particular direction? This could have influenced the way the quantum fluctuations were generated, embedding a preferred axis into the fabric of space-time from the very beginning. This would be a fossil from a time we know almost nothing about, a clue to a pre-inflationary history. There are even more exotic theories. Some have proposed that our universe might be interacting with another universe in a larger multiverse, or that the laws of physics themselves are not quite the same in all directions. These ideas are highly speculative and don't have much evidence to support them, but they show how seriously some physicists are taking this anomaly. The axis of evil is such a fundamental challenge that it forces us to question everything, even the basic symmetries of nature. But what about the alignment with our solar system? This is the hardest part to explain with new physics. If the axis is a real cosmic feature, its alignment with our local neighborhood must be a coincidence. It would be a coincidence of epic proportions, but maybe that's just the way it is. And it's a bitter pill to swallow. It feels like we are back in a pre-Copernican world where our location seems special. Scientists are very reluctant to accept this. The history of science has been a story of progressively moving humanity away from the center of things. First, the Earth wasn't the center of the solar system. Then, the Sun wasn't the center of the galaxy. And the galaxy wasn't the center of the universe. The idea that a fundamental axis of the cosmos just happens to point at us feels like a giant step backward. So, where does that leave us today? The axis of evil remains one of the most significant and stubborn mysteries in cosmology. It's a ghost in the machine of our standard model. Most cosmologists today would probably bet that it will eventually be explained by some subtle systematic error in our data analysis, or that it is just a statistical fluke. This is the most conservative and scientifically responsible position to take. The burden of proof is on those who claim it points to new physics. And that proof is not yet there. However, the mystery has not been solved. No one has been able to point to a specific error and say, aha, this is what caused it. No one has been able to convincingly show that the statistical analysis is flawed. The anomaly persists. It sits there in the data, quietly challenging our most cherished assumptions. This is what makes science so interesting. It's not a collection of settled facts. No, it's a process of investigation. Anomalies like the axis of evil are crucial to that process. They are the loose threads. If you pull on them, most of the time they just come loose and you find a small mistake. But every once in a while, when you pull on a thread, the whole tapestry can start to unravel, revealing a deeper and more complex picture underneath. The story of the axis of evil is the story of a cosmic detective case. The crime scene is the entire universe. The evidence is the oldest light we can see. The suspects range from mundane dust in our own backyard to exotic physics from before the beginning of time. For now, the case remains open. We are still gathering evidence, interrogating our methods, and considering every possibility, no matter how strange. Whether it turns out to be a cosmic mirage or the first sign of a revolution in our understanding of the universe, the axis of evil serves as a powerful reminder. It reminds us that the universe is not obligated to conform to our expectations or our models. It is what it is, and despite all we have learned, there are still fundamental things about it that we do not understand. There are still mysteries hidden in plain sight, written in the faint glow of creation, waiting for us to figure them out. The axis is a whisper from the dawn of time, and we are still trying to understand what it's trying to tell us. It could be telling us we made a mistake in our calculations, or it could be telling us that the universe is far stranger and more wonderful than we ever imagined.